When people hear the word particle, they immediately imagine a tiny, hard dot, like a microscopic grain of sand flying through space. That picture feels obvious, almost unavoidable, but it turns out that this picture is wrong, not a little wrong, but completely wrong. Physics didn't gently update it. Physics demolished it and quietly moved on, hoping nobody would notice how strange things had become. What we still call a particle is not a thing at all. It's more like a momentary shiver in something deeper. Here's the trick your intuition plays on you. In everyday life, objects are made of smaller objects. A chair is made of wood. Wood is made of fibers. Fibers are made of molecules. Molecules are made of atoms. And the brain says, at the bottom there must be tiny solid pieces. But when we finally dug down to the bottom, we didn't find little pellets. We found fields. Fields everywhere. Not fields as a poetic metaphor, but as the actual fundamental stuff of reality. An electron, for example, is not a tiny charged ball. There is an electron field spread throughout the entire universe. It exists even in places where no electrons are detected. When that field is quiet, nothing shows up. When the field vibrates in a certain way, when it gets excited, that vibration behaves exactly like what we call an electron. We give the vibration a name, measure it, track it, and then fool ourselves into thinking it's an object. This is why particles can suddenly appear and disappear. Objects don't do that. Vibrations do. This is why particles can behave like waves, interfere with themselves, pass through two paths at once, and refuse to sit still. They are not misbehaving objects, they are behaving perfectly normal fields. Think about waves on the ocean. You don't ask where a wave is once it passes. The water remains. The wave was just a temporary pattern moving through it. Quantum fields work the same way, except they don't need water. They exist even in empty space. The universe is filled with these fields the way the ocean is filled with water, and what we call matter is just the universe briefly wrinkling itself. This also explains why all electrons are identical. If electrons were tiny objects, making trillions of them exactly the same would be an absurd manufacturing miracle. But if they're all excitations of the same field, of course they're identical. It's the same violin string producing the same note over and over again. So when you hear particle, don't imagine a dot. Imagine a process. Imagine something happening, not something existing. The universe is not built from things, it's built from behavior. What we thought were the bricks of reality turned out to be ripples. And once you really absorb that, the world stops looking like a collection of objects and starts looking like a continuous, restless activity, never sitting still, never made of parts, just fields doing what fields do. When we say empty space, we usually mean nothing is there. No air, no dust, no atoms, just a big blank. That idea worked fine for centuries, because nothing in everyday life forces you to question it, but physics did something embarrassing. It actually looked, and the moment we look closely, empty space turned out to be the busiest thing in the universe. The mistake comes from imagining space as a container, like a box you can empty out. Take everything away, and you're left with the box itself. But in modern physics, there is no box. Space is not a passive backdrop where things happen. It's where the action lives. The quantum fields don't sit inside space. They're what fills space everywhere all the time. Even if you remove every particle you can detect, the fields are still there. And they don't sit quietly. They fluctuate. They jitter. They borrow energy they're not supposed to have, create tiny excitations, and then erase them again before you can point and say, "There, I saw one." This is not a philosophical claim. We measure these effects. They shift energy levels, produce measurable forces, and slightly alter how light moves through what we used to call nothing. A good way to think about it is to imagine the surface of a lake on a perfectly calm day. From far away it looks flat and still. But if you zoom in closely enough, it's never completely calm. There are tiny ripples, thermal motions, random disturbances. Quantum space is like that, except there is no underlying water you can drain away. The ripples are happening in the most basic fabric available. This is why the vacuum can push things around. Two metal plates placed very close together in empty space feel a force pulling them together. Nothing is touching them. No particles are bouncing between them in the usual sense. What's happening is that the allowed vibrations of the fields between the plates are different from the vibrations outside. The imbalance creates a force. Nothingness, it turns out, has opinions. And once you accept that, a lot of strange things stop being strange. Particles popping in and out of existence? That's just the fields briefly getting excited. Energy fluctuations? That's space refusing to be perfectly still. Even the idea that the universe has a baseline energy, a minimum hum that never goes away, that's just empty space doing what it does naturally. So when you imagine nothing, you should imagine a seething background of activity that never turns off. The universe cannot be emptied because there is nothing underneath the fields to empty it into. The so-called vacuum is not the absence of reality, it is reality at its most fundamental. We didn't discover that space contains something, we discovered that space is something. And the biggest illusion we ever had was thinking that nothing was simple. We're very attached to the idea that we are things. Solid, bounded, well-defined objects moving through a universe made of other objects. It feels sensible. You can point to your hand, knock on a table, feel the resistance, and conclude that reality is built out of solid stuff. But once you accept that particles aren't little objects and space isn't empty, this comforting picture quietly falls apart. You don't fall apart physically, but conceptually, yes. And that's where it gets interesting. If everything fundamental is a field, then you are not made of pieces in the usual sense. Your body is not a bag filled with particles the way a sack is filled with rice. What you are is a stable pattern in many overlapping fields. An extraordinarily complicated pattern, yes, but still a pattern. The fields themselves don't care about you. They extend smoothly through space, indifferent and continuous. You are what happens when they arrange themselves in a very particular way and keep doing it for a while. This explains something that sounds mystical until you realize it's just bookkeeping. Every atom in your body is replaced over time, not metaphorically, literally. Atoms leave, new ones arrive, yet you don't disappear and reappear as a new person each year. The pattern persists while the ingredients change. If you were a thing made of things, this would be a disaster. But if you're a process, it's exactly what you'd expect. Think of a whirlpool in a river. You can point to it, measure it, name it, even photograph it. But if you ask what it's made of, the answer is not a special kind of water. The water is constantly changing. The whirlpool exists as a behavior, not a substance. You are much closer to a whirlpool than a rock. The atoms flowing through you today are not the ones from 10 years ago, but the organized motion, the pattern, continues. This also clears up why the boundary between you and not you is fuzzy. Your body is exchanging energy, particles, and information with the environment constantly. Air moves in and out, heat flows, photons strike your eyes and leave again. If you insist on drawing a sharp line around yourself, physics refuses to cooperate. Fields don't recognize personal space. They overlap, interact, and blend smoothly. And once you see yourself this way, something subtle shifts. You stop being a thing trapped in a universe of things. You become an ongoing event in a universe of events. Stability is no longer about permanence. It's about balance. You exist not because nothing changes, but because change happens in a controlled, repeating way. So when someone says you are made of particles, that's a convenient story, not a deep truth. The deeper truth is stranger and better. You are a long-lived pattern in quantum fields, temporarily holding its shape. Not a pile of matter, but a choreography. And the remarkable part isn't that you're fragile. It's that such a delicate pattern can persist at all in a restless universe that never sits still. If everything is really just fields, there's an obvious complaint your common sense wants to file immediately. Fine. Then why doesn't my hand pass straight through the table? If matter isn't made of solid pieces, if it's all just fields and patterns, then solidity looks like a lie, and yet here we are, unable to walk through walls without a trip to the emergency room. So something must be going on, and it is just not what you think. When you press your hand against a table, no atoms actually touch. Not in the way two billiard balls touch. The electrons in your hand and the electrons in the table never collide like little spheres. Long before that could happen, the electromagnetic fields surrounding them begin to push back, hard. What you feel as solid is not contact, it's resistance. its fields refusing to be squeezed into the same configuration. Electrons are particularly stubborn about sharing space. But out of this comes from electric repulsion. Like charges don't like being close, but there's more to it than that. Quantum rules say that identical electrons can't all sit in the same state. So when you try to compress matter, you're not just fighting electrical forces, you're fighting the structure of the quantum fields themselves. The fields rearrange in ways that make further compression increasingly difficult. The result feels like an impenetrable surface. This is why a table can feel rigid even though it's mostly empty space by volume. The emptiness is irrelevant. What matters is how the fields respond to intrusion. Solidity is not about filling space, it's about how strongly the fields react when you try to change their pattern. A brick wall is not solid because it's packed full. It's solid because its fields are organized into a configuration that violently resists disruption. There's a nice everyday analogy. Try pushing two powerful magnets together with the same poles facing. You'll feel a strong resistance long before they touch. No one says the force isn't real just because there's space between them. The resistance comes from the field. Matter works the same way, just with more complicated fields and stricter rules. Once you see this, solidity stops being mysterious and starts being impressive. The universe doesn't need little hard beads to create firm structures. It just needs fields that interact in very specific ways. The hardness of matter is an emergent effect, a collective behavior of fields following simple rules at a massive scale. So the next time you knock on a table, you're not confirming that matter is solid, you're confirming that the fields maki and up your hand, and the fields making up the table are extremely good at saying no to being rearranged. What feels like firmness is actually negotiation failing. And the remarkable thing is not that matter feels solid, it's that something made entirely of invisible fields can be so convincingly stubborn. We like to picture the universe as a kind of cosmic machine. Little parts click together, gears turn, causes push effects, and everything works the way a well-built engine should. That picture was incredibly useful for a long time. But it turns out the universe is not a machine in that sense at all. It behaves much less like hardware and much more like music. And once you hear that comparison the right way, you can't unhear it. In a machine, parts are the stars of the show. Each piece has an identity independent of what it's doing. A gear is still a gear even if the machine is turned off. But in music, nothing exists without motion. A note is not a thing you can hold. It's something that happens. Stop the vibration, and the note vanishes completely. Quantum fields behave like that. They don't produce objects, they produce events. Think about a violin string. Along the entire string, there are many possible ways it can vibrate. Each allowed vibration corresponds to a different note. You don't say the violin contains tiny notes waiting to come out. The notes appear only when the string moves in a particular pattern. Quantum fields are like strings stretched across the universe. What we call particles are the notes those fields are allowed to play. This explains why energy comes in discrete packets. Notes don't slide smoothly between pitches, they jump between allowed modes. A violin can't play half a vibration pattern. It either fits or it doesn't. In the same way, fields don't produce arbitrary excitations. They produce specific, quantized patterns. The universe isn't chopping reality into bits, it's enforcing harmony. Interference suddenly makes sense in this picture. Two waves overlap and produce something new. Not because objects are colliding, but because patterns are combining. Destructive interference doesn't destroy anything. It just rearranges the motion so that the activity cancels out. Nothing mysterious disappears. The music simply goes quiet in that place. This also explains why particles can behave like waves and waves like particles without contradiction. We were asking the wrong question. We were trying to decide whether reality is made of dots or ripples, when in fact it's made of systems that can vibrate in structured ways. The confusion disappears once you stop demanding that nature choose a category that only exists in our language. So when you imagine the universe, don't imagine a factory full of parts. Imagine a vast orchestra with no conductor, playing according to strict but simple rules. The fields are the instruments. The laws of physics are the constraints on the music. And matter, light, and forces are the notes that emerge when the universe vibrates in particular ways. The strange part isn't that reality behaves like music. The strange part is that we ever expected it to behave like machinery at all. Once you really accept that there are no particles, only fields and patterns, there's a quiet consequence that sneaks up on you. It's not loud or mystical, but it's unsettling in a very practical way. You stop being a fixed object. And the universe stops being a warehouse full of things. Reality becomes something that is always happening, never simply there. We're trained to think that change is what needs explaining. A rock just sits there. Motion is the special case. But in a field-based universe, it's the other way around. Change is the default. Stillness is the trick. Stability is something that has to be actively maintained by the way patterns reinforce themselves. You don't exist because nothing is happening. You exist because an enormous number of processes are happening in just the right balance. This flips how you think about fragility. You might imagine that being a pattern makes you weak, easy to erase. But patterns can be astonishingly resilient. A flame is not a thing you can pick up, yet it can persist for hours if the conditions are right. A hurricane has no solid core, yet it can rearrange entire coastlines. What keeps them alive is not material permanence, but continuous renewal. You work the same way. Your body, your mind, even your memories are ongoing processes. Neural activity isn't a storage box filled with thoughts, it's a constantly refreshed pattern of electrical and chemical activity. Interrupt the pattern, and the thought vanishes. Maintain it, and the experience continues. There is no thing to point to where the thought lives. It exists only while it's happening. This also takes some pressure off the idea of identity. If you are a process, then you don't need to be frozen in place to be real. Growth doesn't threaten your existence, it is your existence. The fear that change means loss comes from treating yourself like an object. Processes expect change. They survive by adapting their pattern, not by resisting it. And here's the part that's easy to miss. A universe made of fields doesn't trap you, it connects you. Fields overlap, they don't stop at borders. The same fields that make up you extend outward into the rest of the universe, interacting with other patterns everywhere. You are not a thing isolated in space. You are a localized activity in something continuous. A knot in a cosmic fabric, not a bead on a string. So when physics says there are no particles, it's not taking meaning away from you. It's quietly removing a bad metaphor. You are not a little object drifting through an indifferent void. You are a temporary, self-sustaining pattern in a universe that never stops moving. And the remarkable thing isn't that you'll change someday, it's that, in a world built entirely for motion, you can never feel stable at all.